In chemistry, we often write ionic equations, which show soluble chemical species as ions solvated by water. And we use the aqueous phase to show this. And this is specific to ionic compounds only. And there are three different types of equations that we'll look at. The first is the molecular equation, where all species are still intact. We show the whole compound for the ionic compound, and we don't break them into ions yet. And soluble ionic compounds get the phase indicator aqueous. So we need to look at the solubility rules to be able to tell which species are soluble and which are going to be solids, or the precipitates. The total ionic equation shows all soluble ionic compounds as broken up into ions. And we need to include the charges and make sure you include the phase, which is aqueous. And anything that is solid cannot be broken up into ions or gases as well. The net ionic equation shows only the species participating in the reaction. The spectator ions get canceled out, and I'll show you what I mean by that in just a minute. So let's take a look at an example. The molecular equation we're going to look at is the reaction of calcium nitrate plus sodium sulfate. So calcium nitrate has this formula, and if you look at your solubility rules, calcium nitrate is soluble, so we'll indicate that it's aqueous, and that's going to react with sodium sulfate, and that is also soluble. So usually everything on the left side of the arrow is going to be soluble. And so what we need to do is switch the ions. So now the calcium is going to pair up with the sulfate, and then the sodium is going to pair up with the nitrate. Okay, so we switch the ions and see what the solubility is of the compounds on the right of the arrow. So calcium sulfate looks like this, and then sodium nitrate we have there. And if you look at your solubility rules, it says that all salts of sulfate are soluble except for those with calcium, barium, strontium, and lead. And so calcium sulfate is one of those exceptions, and so that's going to be a solid. And sodium nitrate, always soluble, so that will be aqueous. Now, for the total ionic equation, we need to break up any soluble ionic compounds into the constituent ions. And don't forget to balance your equation, like I did. We need a 2 in front of sodium nitrate. So the total ionic equation shows all soluble ionic compounds as ions, aqueous, and remember we can't break up any solids into ions. So we need calcium 2 plus, don't forget the charges and the phases, plus 2 nitrate ions. So this is where things get a little bit more tricky for students. You need to realize that the 2 subscript around nitrate means we have 2 nitrate ions, plus 2 sodium ions, and a sulfate ion. And calcium sulfate we cannot break up into ions, so that remains a solid. And then what we have left is 2 sodium ions, aqueous, so everything that's an ion needs to be aqueous, and 2 nitrate ions, also aqueous. Now for the net ionic equation, we only show the species that are participating in the reaction. Everything else is called a spectator ion, and you can think of this equation like a mathematical equation where the arrow is an equal sign. If you have 2 things that are exactly the same on both sides of the arrow, they will cancel out. So if we look at the total ionic equation, right, calcium 2 plus is only on one side. Same with sulfate 2 minus. Calcium sulfate is only on one side. And these nitrates and sodium ions are all the same on either side, and there's the same number of them, so they will cancel out. So these are called the spectator ions because they're not actually participating in the reaction. They are just hanging around, balancing the charge. So our net ionic equation is calcium 2 plus sulfate ion forms calcium sulfate solid. That's called the precipitate. And this is a precipitation reaction. The only reaction that occurred is that calcium ion and sulfate ion got together to make calcium sulfate.